the polygonal mesh have 3D coordinates. So if we have, actually I do it in Blender right now, we have the x-axis, the so the x-axis is left to right, with going screen right is positive x. The y-axis is actually into the screen, like that. That's the y-axis, so that's going into the screen, that's a positive y. And the z-axis, or the z-axis, that's going up and down, and that's z. So knowing the coordinate system, so first of all, there are different conventions in different fields. So in other software, usually x is left and right, but y would be up and down, and positive z would be going outside the monitor or the screen display. It's not a convention. It's different conventions in different fields. So what axis is up, which axis is, which direction is positive or negative, the left hand rule or right hand rule, which I won't get into, but that is figuring out if x is here, and then using your right hand and curl your fingers to go towards the y. The direction of your thumb is where the direction of your z-axis will be. Left hand rule will be the other way around, and that means if this was the left hand rule, that means your left hand, the palm will be, well, your fingers will be facing aligned with the x-axis, and then your palm will be facing where y would be, and you curl it, and your thumb would be pointing down. That would be the left hand rule. You don't have to memorize this right now, but I'm just explaining there's a lot of things that goes into it. Even units, every software, units could be arbitrary. What I mean by units of the metric of it could be one grid, or 1 unit is 1 centimeter, or it's unitless, or 1 meter. And also whether it's clockwise or counterclockwise. So if you make the vertices or points, how you connect or create the faces, it depends on if it's going to be drawn clockwise or counterclockwise. These things matter. You don't have to know them right now. We'll come across it. And it's probably more important either when you start, well, it does when you start dealing with lighting and materials and whatnot. But just for now, we'll keep it simple. Also, as well, for the surface, knowing the normal and UV textures and how to lay those out. But we'll come across those when we need it. So right now, what we need to do is just figure out how to draw the points in space. So if let's say this is the XY axis, the XYZ axis, right? And we want to draw a plane. Each along here, just like in school, you'll have different, I can make this smaller. Let's say that's like, different units for each one of these, right? So that's like 1 unit, 2 unit, 3, 4 right here. It'll be the same type of thing for over here. 1, 2, 3, 4. And it also goes negative, right? So this could go in the other direction, and that will be -1, -2. Basically, you're making like a Cartesian plane, right? And here that would be, the units would be 1, 2, 3, 4. And you have the same thing for up here, right? 1 unit, 2, 3, 4. And again, these go negative, and that will go negative as well. So if we're using this, what if we wanted to draw using the vertices to make a polygon mesh? If we have vertices or points, edges that make up a face, what we want to do is create, basically, I'll just use black here. Let's say we want to make a plane. We could say a plane is here, here. So these are the vertices or the points. Now I have to connect the edges. right? And once you connect the edges, then you make a face which will fill in inside there. So I'm just going to kind of color it to denote that. Oops. So if you were to color inside here, that'll be like the surface of the face. Like that, right? So anyways, I'll leave that. Actually, I'll put it back. And I'll just fill in. That'll be the color. That'll be like the face. I'll just lower the opacity a bit. Okay, so let's say we make a polygon and we're making a plane. So how we define this, I know this is not really to scale because they're just drawing, but what we could do here is that we'll say the first vertex, let me make that smaller. The first vertex was this one, right? That one, we call that 1. So we'll just say vertex. Actually, let me make that smaller. So that point, we'll call it vertex 1. We'll give it the 3D coordinates. We'll give it the X, Y, and Z coordinates. So that one, we'll say, I know it doesn't look like it here, but we'll say it was 1 unit to the X. Let's pretend that's 1, even though it doesn't look like it in my units what I drew here. But let's say it's 1 unit to the X. On the X-axis, positive. Well, we're doing Y over here. So Y, the Y-axis, the positive Y-axis is this way. But we're going to that point here, this point. So we're going to say that's -1 on Y. And then Z, there's no height to it, so Z will be 0. So vertex 1 is going to be 1, -1, 0. Then we're doing counterclockwise because in our software, counterclockwise will be the direction of the normal. A normal, and let me just redraw this here. So if we make a face like this, whatever, let's say from here to here, here to here, I'll just draw it in and erase that top part here. So a normal is whatever the face is perpendicular to it. So the flat versus the flat part of the face is here, so the normal is perpendicular to that, right? So okay, so if we're creating vertices in counterclockwise order, it's going to go like that. The normal is going to be, that's how the software will know which direction to put the normal. And that's that explanation. So I'll just delete this for a second. All right, so back to the vertices. So that's vertex 1. Vertex 2, it's going to be, okay, so it's 1 on this we're looking at this point. So it's going to be 1, we're calling this 1, even though the number says 2 here. Pretend that's 1 unit out on X. Okay, and then on Y, now it's positive Y. It's going to say back 1 unit. So that's 1. And still there's no height on Z, so that'll be 0. Okay, so that was 2. Vertex 2. 1, 1, 0. That's the coordinate. Vertex 3 here. Vertex 3 is, okay, so on X is negative on the X-axis. This is this point here. So that's going to be, we're just using units of 1 just because it's easier to visualize at the moment. So that's -1. It's positive on the y-axis, so it's y1. And then the height is 0. And then the last one, so that's, -1, 1, 0. And the last one, vertex 4, vertex 4. So this is this one here. So it's -1 on the x-axis. And it's a -y this time, so -1 on y. And it'll be 0 because there's no height. So that's -1, -1, and 0. All right, so now that we have that, let's draw this polygon so we can see it in our 3D program. And we're going to do it the old school way, where you didn't actually have the 3D tools. You could actually have to type it out in a notepad. So it's kind of like a code. And this is how modeling was done before 3D tools used to basically do this for you. So we're going to draw, or basically describe, this polygon or this plane using a format or a file format. The one we're going to use is OBJ or .obj. It's a popular modeling format that a lot of 3D software created. You could read about it on the Wikipedia or probably on the website to find out the exact specification. Now, there's a lot of information that could go into an OBJ file, including the material. Well, you can mention on the top here. It's a simple data format. So there's many different file types that you could describe. And if you go into programming, there's different ways you could do the data structure, but we're not a programming class. You just need to know, or you need to understand how we're saving a vertex, an edge, and the faces. And this will make you understand how we could model in 3D as well, what's actually happening. But inside there, you could save the vertex position, the UVs and normals. We're not going to worry about that stuff. We're just going to worry about recreating these vertices here. So you can read about all this, and if you're a programmer, you could go through all this stuff, but we're just going to do a simple example just to illustrate. So the OBJ file is actually, you could just create a text file or open a notepad. Don't use basically a text editor, not a word processor like Word, because it adds extra like decorations and formatting, which will ruin your code. But if you have a notepad in here, you could open Notepad and save it in a location. You could have to call it, we'll call it, the name of the file doesn't matter as much. We'll call it my model, we'll call it. And the extension is .obj. And I say yes to accept it. If you don't see extensions, you might have to go to View. Actually bring that out. I have to go to View and show file name extensions. If I turn it off, I will not see the file extension anymore. I just have to wait for that to calculate to update. You might have this where you might not see it at all, right? So you could go to View, file name extension, and you'll see that extension there. So once you have that, you can either go into the notepad, go file, navigate here and open it, or you could drag and drop it. And you could see now that file is open in here. It's just a text file, even though you change the extension. So it has the name of the file, so it's open. So the way the format works, you could go into the Wikipedia and read all the information, but we only care about right now the first part. You could go in here, for example, say Vertex Indices. So basically how you describe a vertex, they start off at vertex 1. It's 1 base. So the first one is, the ID is 1. Each vertex have an ID. So the first one, the vertex ID is 1, is not 0, at least in the OBJ format. And when you define a vertex, you just say V, right? And then you give it the XYZ coordinate. You could give it a W, but it's not needed. It's an optional one. And if you don't know what W is, you don't have to worry about it right now. It's not a math course. We're just trying to be able to draw this into a format that the software can understand. So we're going to do vertex 1, and we'll call it V1. That the first x-axis is the value on the x-axis is 1. So you put V space 1 space on vertex 1. We said -1. So -1 space 0. So the first vertex, and it knows the ID of the vertex by the order. So that's the first one we put. So that's going to be vertex 1. And the XYZ coordinates is 1, -1, 0 with spaces in between. So vertex 2 is going to be 1, 1, 0, like we see here. Vertex 3, and each vertex you have to skip a line. You have to press enter to go to another line. Vertex 3 is -1, 1, 0, and vertex 4 is -1, -1, 0. So if we save that file is in here now. So if we now go to our software, Blender, you could go to File. Well, actually, let me click in here. I'll delete these. I'll select everything and press delete, and they're gone. So if you go to in here, File, Import, and you go into Wavefront OBJ, and you click on that, and you navigate up here. You can use these buttons or type in where you save your file, and you'll see in here you have my model. Now, one thing, as I was mentioning in the earlier videos, when you're importing this, one thing about it is that the orientation of it, like you see in Blender, we have over here, X is positive, Y, X is positive, that's left to right, Y is in and out of the screen, positive Y is in the screen, and Z is up. Now, that convention is not the same for everybody. Other software have Y is up. So before I import this in the options here, with Blender, this version of Blender, the options over here, I have to define what the forward value is. So looking at that, positive Y is back, meaning going inside the screen. So that means -Y is forward. That's positive Y. So -Y is forward, and Z for us is up. And that corresponds to the drawing we have here, where X is positive, Y positive. X is positive to the right, Y is going to the screen, which means -Y is forward. That's why we put -Y forward here. And Z is up. That's why we put Y is up over here. So now we're basically, when we import the file, at least it knows how to interpret it. We define our coordinate system. So we select the file, press import, and you'll see that now we have these vertices. Now, right now we're in object mode. We'll explain the different modes in here. So if I try to select one, you're actually selecting the object itself. But if you want to select the vertices, you have to go into edit mode in the drop down. There's different ways you could get to it as well. If you hold like Control Tab, you have this wheel here, and you can go to edit mode, or you can Control Tab and then press 6 because you have 6 over there to go to edit mode. And when you're in edit mode, then you have these 3 icons here. One is for the point or vertex. They're the same name. The other is for edges, but we don't have any edges because we just defined vertices. And the third one is for faces or polygons, which we don't have because we didn't define them yet. So we go back to points or vertices. You'll see that you have the points here. Okay, so we have that. I'll go back to object mode. I could click here and press go to object mode. So basically, you can think of the object that's what you see here in the outliner, and it has all, when you select it, it's kind of like grouping all the points and edges and polygons into one. So if you select any one of them, you're selecting the whole group as a whole. If you want to move them individually, you have to go into edit mode and then choose what's called the components, the vertex or the point. That's interchangeable. The edge or the side. The words are interchangeable. The term is interchangeable, and the polygon or face. Okay, so I'm going back to the vertex here. Going back to object. Select it and I press delete to get rid of it. So it got rid of the whole thing. So what I'm going to do is go back and edit this file because I only had vertices in here, which is fine. Now, remember the order at which I put these in matter because this vertex is vertex 1. I know because the first one here is not numbered, but that's how the software will know. Because the order of which they appear is the vertex ID. So that's vertex 1, 2, 3, 4. But I put them in a certain order. So it's going, this is vertex 1, vertex 2, vertex 3, vertex 4. So it's going in a counterclockwise order. So if I were to draw that, like this is vertex 1, this is vertex 2, this is vertex 3, this is vertex 4. This is as if you're looking from the top. The order, you're going into a clockwise direction. From 1, 2, 3, 4. The order will make it's known because the order of which you identify these points will be the direction of the normal. So how do you define a face now? So what you do to make a face and the file, you press an F so that's a face, and faces go by the vertex ID. So we want to do this ID, which is the first one. So I say I want that. The face is going to take vertex ID 1. Then I'm going to take vertex ID 2. Then 3. Then 4. If I save that, and then I go back into Blender, and then I import it again. So File, Import, OBJ, the wavefront OBJ. So I'm going to select it. So it should still have the same settings if I did not reset it. So yeah, so Y, negative Y is forward. Well, in this case it's forward over there and Z is up. I select my model that I just saved, which is the notepad I saved, press enter. Now I have a face. And you can see you have a face over here. So now remember we're in object mode. So I click away and then click back on it and I have it selected. I can't see everything. So if I select this and press edit and I'm in selection mode and I'm in point or vertex mode, then I could select each point. Right? If I'm in edge mode now that the thing is, I only defined a vertex and a face. It knew from the order to make edges in between. So the OBJ file format do not define edges. You define the points. You define the points where they are in space, and the faces you say what point ID make up the face. So now if I go to edges, I can select the edges. And if I go to face, I can select the whole face. Now, I'll just give a sneak preview of what you could do with this. So if you select a polygon, well, I went back to edges here. If I select an edge, it's a point, a vertex. I select a point or a vertex, or sometimes they call short vert. I select it. If I go to move tool, I can actually move that individual point like that. Well, right now 3D snap is on. I could turn that off here. See, you could move the point or move it like that. And then this is how modeling works. And so in the 3D software, this allows me to basically update this structure or file structure without actually typing it out myself. So that's what the 3D tools are doing. It's actually creating this structure in the background. It might be represented differently. In the OBJ format, that's how they save it. There's other formats such as You go import like FBX. They all save points. They all have different ways of structuring and information. Like FBX have animation in them, whereas the OBJ don't. At least I don't believe it. It doesn't have any animation in it. They have more things inside it. And then when you save a Blender file, it saves all this information as well, plus a whole bunch of other things as well. But at its core, the structure is pretty much the same. It has points. It knows where they are in space, and it knows how the faces are made based off the points or the vertex IDs. And these tools, what you're actually doing is when you're actually taking that, I could undo, Control Z to undo. I could go now to edge. I could select an edge, and basically you're manipulating the polygon mesh without doing any code or actually writing out anything. And that's what these modeling software does. And just one thing I want to mention, if you're taking an object as a whole, I went to the object from edit mode to object mode. So if I select an object as a whole, and let's say move it, everything will move, right? That's because you're actually moving the actual position or the space, the pivot, or where this object actually exists in the world. But so that's a rigid movement, right? But if you go to edit mode and I select the point or the vertex mode, you select that and I move it, the origin of the object does not move. You're just moving the point. So if I undid that, select everything and moved it, the origin of the object, if I go back to object mode, if I select that, you notice that that point is still at the origin because the object didn't move. You just moved the components of the object. So that's known as deformation. If you move the components, the vertices inside. And by moving the vertices, it in turn affects moving the edge, which in turn affects moving the face. So if I did undo, I go from edit mode back to object mode. If I select that and move it, notice that if I select it, the manipulator is here because the point or the origin moved, because I actually moved the whole object. Whereas if I undid that, I'll just do that one more time. Go to edit mode, select all the points and move it. I deformed it, so the object didn't move, but I moved all the points in the object. So if I go back to object mode and select it, the origin did not move. And so if I move it now, you see that its relative position stays the same as what it was because I moved the points. So that's how modeling works in general. This is how modeling was done in the past, like in the 80s, for example. Models were done in whatever, if it's TextPad or whatever software, you actually had to put in the points. And if you had to animate it, you have to say every frame where they will be. One other thing I want to mention in here, if you have your face like this, if you go into edit mode and select the face, while you're in edit mode, you click down on the overlays, the drop-down menu over here. You have the normals, and you could click this one, display normal lines. If you click that on, it doesn't look like anything happened, but there's actually this line, this blue cyan line that comes up. If I go back in here, turn it off, you'll see that it showed up. I can make it bigger by choosing the size, so it's a visual indication for you. This is a normal, and the order of which, remember we were talking about the order counterclockwise. If we did it, we put this counterclockwise, that means because this is point 1, point 2, point 3, point 4, or vertex 1, vertex 2, vertex 3, vertex 4, the IDs. Because we did it in counterclockwise, it knows that the normal will be this way. Now, it's not that way, right? If I went back and changed the order of that file, instead of the faces vertex ID 1, 2, 3, and 4, we'll reverse it. So that means instead of going 1, 2, 3, and 4, we'll go 1, 4, 3, and 2. So that means it's going the other way. It's going clockwise. So 1, 4, 3, and 2, and save it. Let's save that. We're gonna have to re-import this. So I'm going to just select this. Well, go to object mode, select this, delete it. Now I already saved it. So if I go in File, Import wave.obj, take my model. Now it doesn't look like anything happened because we don't have our display on. So if I select it, go to edit mode, because we still have our normal on, now you notice it's going the other direction because it's going clockwise. So based on the direction, that's where the normal is. This is why does this matter? Like basically you want to know what direction is up, and lighting, when we get into that on surfaces, it will know how to treat that, which way is up on the surface. Another way to show it, I'm going to go back here and reset it. So the size was 0.1 and I'll turn it off. Another way to show it is over here where you have your shading. One of the options is what's called backface culling. So what that means is whatever the up side is of this face, the other side will not be visible. So I'll go back out of here in object mode. You see right now it looks invisible because it's upside down. Like this is the top of the surface. So only in 3D software, usually the direction of which your normal face, you'll see the surface, but the other side, you don't. It's like invisible. That's how it's drawn. And in general, a lot of 3D software or engines look at it that way. And they might have an option that allows you to do both sides, double-sided faces, but by default, it's not by default. Like usually, it's only one side. So if you define that's why it matters. Like, so if you define your order or which direction is up of the surface, if you were to look behind it, you'll see nothing. And that's why in a lot of games, especially older ones, you might see something like a face here or an object or a 3D object here. When you go behind it, you could see through it because it's an optimization. It's it requires that you do not have to draw the same face twice for the front and the back. You only have to draw for the front. So again, it's because if I turn that back on, the normal, go to edit mode, select that face, I was in face mode when I select it, and I go here, and then I turn on normals. And when I say here, that is the viewport overlays. And I'll just make that bigger so we can see it visually. Because the normal is facing that way, we see the drawing of the face, but the other side, well, if I go out to object mode, we do not. So that's what the normal is indicating, which way it is. So now I'm going to go back and turn off backface culling from the viewport shading. So it looks double-sided again. But remember, it's upside down because of the normal. But it doesn't matter because I'm going to go in object mode or go into the outliner, select it, and delete. What we're going to do is basically an exercise where what we want to do is make a cube. I'm not going to draw it out. I'm going to try to visualize it here. So I'm going to create another file. I'll just copy this and paste, and I'll just call it my cube. And I'll drag and drop in here. So now it's my cube in the notepad. I'll delete the face. So basically, the vertices in the cube is going to be the same, right? And what I'm going to do, so I'm going to keep that for the bottom, but I want to have vertices on the top as well. So what I'm going to do is just copy that and paste it. And I'll call this, well, basically, if you go back to the Wikipedia here, you notice that in the file format, you have like the ampersand here, or the pound. It's not ampersand, the pound sign, or the hash tag, I guess you could call it. That's what's a comment. So basically, you could put instructions, is mainly for the programmer or the person looking at the file to know what it means. The computer does not read this. So what I'm going to do is just basically use that to help label my sections. So this, I'll call this, I'll put the pound here just for me to know. This is a face polygon bottom. Like that. So these polygons are the bottom of it. So you can notice you could put extra spaces, you could skip lines, and it's okay for the file format. It accepts that. So the bottom face, I'll say vertices for polygon bottom. And then here, I'll put another comment, basically another comment there. So I could see I separated here. And I'll say faces for the polygon bottom. And for this first one, I don't remember, we just went over counterclockwise. It's going to face up. So I want to put the faces, the vertex ID counterclockwise. So it's going to be, instead of as if I'm looking from the top here, instead of 1, 2, 3, 4, I'm going to put 1, 4, 3, 2. 1, 4, 3, 2. So basically now that polygon face is pointing down. And let's do this one as a top. So I'll copy that comment there. So vertices for polygon top. Again, this is just for our labels because it has a comment in front of it. So that basically you're telling the computer, don't read this. But it's for us to know if we're looking at this section. I know that's what it's for. If you take these out, it'll still work. It's just that it's harder to read for us if we were looking at the code. So basically, we're making a cube. So basically, the top one is the same vertices, except that I'm going to move it up 1 unit on the z-axis. So this is x, y, and then z. Instead of 0, it's going to be 1. It's going to be 1 for all of them because I'm moving all the points of them up. Right, so we have the first 4 vertices, and then the next, so that's vertex 1, 2, 3, 4. Then it's going to say vertex 5, 6, 7, 8. So I'm going to copy this for the faces section, paste it here. So faces for polygon top, right? So now the faces for the polygon top, I want them to be in counterclockwise order because I want the normal to be facing the top. So now I just move these up. So this is 1, 2, 3, 4. If I move these up, it's going to be, the ones on the top are going to be, maybe I should draw it out. So if I move this to the top, so I move these up, and we're going to have another one here, 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 and here. I'm just going to draw the lines here. Basically, I want the points going to be here. So this is going to be 5, 6, 7, 8. That's the order of it. So that's vertex 1, 2, 3, 4. Those are the ones on the bottom. And then 5, 6, 7, 8. So this is basically the same thing as over here. 5, 6, 7, 8, and I want to move it in counterclockwise. So it's going to be face over here. The next face is 5, 6, 7, 8. So I define 8 vertices. The first 4 is for the bottom polygon. 1, 2, 3, 4. And the next 4, I copy that and move it up. So then that's 5, 6, 7, 8. But so that define all the vertices. Now for the top polygon, the bottom polygon, I'm taking, that's 1, 2, 3, 4, but I don't want to counterclockwise because I want it to be facing down. So I say 1. That's why I have 1 for vertex 1, 4, 3, 2. So I'm going the other way. But the one on the top, I want it to be facing up. So I say vertex 5, 6, 7, 8. So if I save this and bring it in here, I could go import wavefront obj, and I'll do my cube this time, making sure I have the coordinate system in the right direction. Y is forward, Z is up, and press import. And you'll see now I'll have the two faces over here. They're not connected because I only defined the bottom and the top. So if I select the object, remember if I select it, it selects everything. I have to go to object and then edit mode. I guess I still have this on. If I went to the overlays and I have the normals on and I change the size to 1, you'll see that this one's pointing up, but the bottom face is pointing down. And so if I go into the viewport shading here and then say backface culling and turn it off, right, and I'll go back to edit mode, you'll see that the top, you'll see it, but you don't see the bottom because the bottom face normal is down. The backface culling gets rid of it. Think of like PlayStation 1 games where, you know, if you go behind the wall, you don't see it. But then when I move, now I don't see the top because the normal is pointing up, not down. So you only see the first side, and now you see the bottom. So at least we have a cube. I'll just put back on backface culling so I can see the top and the both sides of the plane. What I want to do is I already have all my vertices. I just want to connect the faces now of the vertices. So let's do the front one, right? So if I'm looking at that, I know this looks kind of confusing now, but the numbers here is vertex 1, vertex 5, vertex 8, and then vertex 4. Yeah, so 1, 5, 8, 4. So I don't have to make any more vertices because I have all the vertices. I just have to make another face. So I'll copy this, paste it, and I say faces for polygon front because we're making the front one. So it's vertex 1, vertex. If you could see the numbers, it might be hard to see. Let's see if I get rid of that. Can that help? So that the top one's 5 and 8. You see here. I guess I drew everything else on the other ones. Okay, so the bottom ones is 1 and 4. So starting a vertex, and we're doing counterclockwise. So vertex 1, vertex 5. So vertex 1, vertex 5, vertex 8, and then vertex 4. Let me just draw it as another. Well, I could draw it up here basically. So up here we have the same cube, right? We'll have so this is vertex 1. This is the bottom one. 1, 2, 3, 4. So that's doing that. And then we made one on the top here, 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 here. This is a terrible cube, but hold on. Let me just undo that for a second. Let's say here and here. This is just a rough drawing, but so this one is 5, 6, 7, 8. So the front is going to be vertex 1, vertex 5, vertex 8, vertex 4. That's where we got that 1, 5, 8, 4. So if I save that, so that's the front. So I'm going back to object mode, select this, delete it, and I'm just going to import wavefront and take the cube again and press import. And okay, so I mean it drew this side, but that actually looks like it's the back because X is to the right. I'm trying to look at this to orient it. X is to the right, Z 1, 5, 8, 4. I believe that's correct. But apparently it's going the other direction. Well, it seems like this is an example of why coordinate systems are important, or it's hard to interpret. So if we go back here, if I go back to import the object, go back to cube, you could reset the settings here, how the axes are interpreted. So if I restore them, it's going to put Z, put it back how it was by default. So negative Z is forward. So in this case, I found out that this coordination, the way it works, the way it's coordinated, having Y forward and Z still up seems to import it how I expected in my coordinate system that I drew. So now, so I have this over here, X to the screen right is that way, Z is up, and Y is in and out of the screen. That matches with what I was trying to draw with my coordinate system here. So that seems to be the settings when you're importing here, if you want to match it with my coordinate system that I drew for the example, where forward is Y forward and Z is up. Okay, so continuing. Now let's do the back one. So basically I'm going to just copy this, gonna paste it, and I'm going to write back. And the back is going to be, let's see, this was counterclockwise. So this one, looking from that side, it's going to be this rotating this way. So it's going to be clockwise. So 2, 3, 7, 6. 2, 3, 7, 6 for the vertex order. So if I go back here, I saved it, delete that in object mode, go to File, Import, OBJ, my cube. It kept that configuration. So you can see now I filled the back. Now let's fill the side here, which the vertices we need. So now for the side, we'll have this, we'll call this, looking at the screen, is going to be, well, if we're doing the convention of a character, this will be facing forward. So on the screen right is considered the character's left, or in this case, the object's left. So this is going to be the left. That's the convention. So positive X is going to be the left side, whereas it's forward, looking forward is the negative Y. So as if, I'll show you what I mean. So if I go back in here and delete this object, if we go to, let's say, add mesh and choose monkey, it's a Blender object that they created. It's called Suzanne, the monkey. They name it Suzanne. But basically, this is the front of the character. The character, if you look at the point of view of the character facing forward, if you go back here, facing forward of the character, this is the orientation of the world. So the negative Y is facing forward, and the positive X is going to be considered the left side of the character here. So even if we're looking at it screen, for example, the ear, that is the screen right of the ear, but it's the left side of the character. So that's going to be called the left ear. And the characters, this is going to be considered the right ear of the character, but it's screen left for us. So with that being said, this is why I'm calling this polygon left, because I'm doing the face of this cube. So it's going to be, so if I'm starting, I can start off with 1, I guess. So 1, 2, 6, 5. 1, 2, 6, 5 should work. 1. So vertex ID 1, vertex ID 2, vertex ID 6, vertex ID 5. 1, 2, 6, 5. And that should define the left side with the normal pointing out. So I save this. I'll go back in here. I could delete this. Go to File, Import, OBJ, My Cube, Import. And now that side's filled, the top is filled, the front, the bottom, the back. We just have to do the left, or the box right side of it, the right of it. So it's also interesting as well, the interpretation of it, because it's supposed to be 1 unit high. Yeah, I see why. Because this is 1 unit out and that's 1 unit back. So combined, that's 2. And this is only 1 unit high. So that means I have to make this, the z-axis 2 up. So it's a cube. So let's fix that first. So if I go here, so the bottom vertices stays at 0. The point, the XYZs of the vertices. So the X component, we have 0, but in this one for the top, I moved it up in 1 for the Z-axis. I'm going to change that to 2 for all the top vertices and press save. I'll go back in here. I could select this cube, delete it. File, import, OBJ, bring the cube. Okay, now it's big enough in here. Great. Next, what we need to do is then just finish this left side here. Let me close, bring that in. Well, I say left side. It's a character right, the right face that we're missing here. So I'll copy that, and it's faces for right. It's not face. It's not plural. It's face. Again, these are comments, so it doesn't actually fix the code. It's just for your labels, so you understand. So on the right side, on the cube, we can start off at 4. So we could say vertex ID 4, 3, 7, 8. And I'm doing it counterclockwise if you're looking from that direction. So that means the normal will be facing out that way. So 4, 3, 7, 8. 4, 3, 7, 8. So now that I save that, I'll go back to Blender here. And let's go File, Import, OBJ, My Cube, Open. And now it should be complete. Actually, I restarted the scenes. You go back to New, General, don't save anything, select everything and delete, just because of material seemed to be applied to it and I didn't just start it over. So they have the same original material. So you can go to File, Import, and the material is a dark gray, so it's hard to see. So you go to Wavefront OBJ to open it. Yeah, so opening it in here, just make sure that we have, if you reset it like I just did here, you have to just change the settings again here. So forward is Y forward and Z is still Z up. Up is Z up. Select My Cube and press Import. And now we have a cube. If we're looking from here, this is the front. And as you can see that they are all facing the same direction. If you click on here and do backface culling, you'll see that, oh, well, this direction is not correct. So the order here is not correct. This is, which side is that? If I'm looking, that's the negative See, that's negative x. This direction is negative x, so that's the right side. So if I look here, polygon right, I said 4, 3, 7, 8. That should have, I believe that should have been right. 3, 7, 8. Oh no, that's going clockwise. 4, 3, 7, 8 is going clockwise. Well, it's 4. Yeah, it's going clockwise. So it should be 4, 8, 7, 3. So it's 4, 8, 7, 3, and save. So if I go back in here, you see right now with back face culling on. So it only draws the side of the normal. So you see, this is an example of why you see old games, or maybe even some now, where it looks like everything is being seen through. If I delete this and then go back, I already saved it, the change. Go back and import it. My cube, import. And okay, so it looks like it's fine. Let me just double check that I'm in the viewport shading. Backface culling's on. So that means it's only showing the side that is correct. The side that has the normal. The other side will not be drawn of the face. And that's pretty much it. So this has been modeling a cube, basically line by line, or basically defining the vertices and then saying what the faces are. So this how it was done in the past. As you can see, how much time and how much you have to think about the coordinate system and how complicated this is with just a cube or even a plane. If you want to do a more complicated object, if I just move that out of the way, deselect and then add mesh monkey. Yeah, well, you could see over here that if I were to do that, if I wanted to draw this out, or you could definitely like take this and export it out, and you can see what the Obj file of this would look like. So you could select, I'll delete the cube. I'll select a Suzanne or the monkey here. File, export the wavefront OBJ. And in here, we'll call it Suzanne, because that's the name. That's the name of the object here. And well, you see, if it's using this default, well, it's not even the Blender's orientation system. It's probably from the original wave, from the original creator of this file format, the Wavefront. When they made it, that's probably the coordinate system they were using. So we'll just export that. So now this model has been exported, or this polygon mesh has been exported. And here it is. And you could see right away, it brought in a .mtl. That's for an OBJ can refer to an MTL for the material. We did not use that. I mean, you could read this or read more of the format. There's a lot more things that you could put in and define in an OBJ file. We're only using the vertices and the face. But just to show you, when you open a notepad, so this one's ours. If we go over here, take Suzanne OBJ and drag and drop, you'll see that it has, you know, the comment, and it's telling you where this file is generated from Blender and where to get it. Here is telling you there's the MTL lib or material library saying, hey, if you want the definition of the material that's in this file, we did not use it in ours, right? Then they had this Suzanne. They explained that with the O, which we did not use, and here's the vertices for these are all the points or all the vertices of the character. And then the normals, the faces. The faces also have UVs. That's why they're in a little different format. But anyways, ignoring all the extra information, just the vertices alone, that's all we really did. If we just compare them, it's really defining every single point or every single vertex inside that model. What's going on, everything with the V here. So if we just bring this back Again, if we go to select the Susanna or the Bunkie, go to Object, go to Edit Mode, these are all the points. And if I go to the points and select, these are all the points that in the Suzanne OBJ file is defined. Well, that's the VT. Yeah, over here. The V, these are the vertex, the X, the Y, and the Z coordinate for every single one of these points right here. So it's possible to model in Notepad, but Blender, as well as many other 3D software, have tools so you don't have to, and you could deal with a lot more points and not worry about at least those technical issues. But I just wanted to show you what's actually happening under the hood. Every single 3D software is doing basically the same thing, and Game Engine, they're pretty much doing the exact same thing. They might represent it a little differently, but under the hood, they're all doing this, just defining these points. And the tools that we're using help streamline that so you don't have to worry about that.
Thank you for watching. Remember to like, comment, subscribe, and hit the notification bell.